Hello, my name is Johnathan, and today I'll be showing you how to generate bioisosteric analogs using your lead compound and a program called BROOD, a computational program that generates bioisosteric analogs based on your specified location within your lead compound. Bioisosteres are chemical groups with similar chemical and/or physical properties that produce similar biological functions. Generating new analogs and replacing them at a specified location within a lead compound can help reveal potentially new connections to the protein, which can have an effect on certain physical or biological properties, such as efficacy, potency, and toxicity. So you can find BROOD by going to the search bar, typing in BROOD. Right here, click it, open up. It's a bunch of little ducks there. The first thing you're going to want to do is to click here, build a new query. There'll be a file icon next to molecule, and from here you can upload your lead compound as a .mol2 file. Once that opens and loads, you can use your mouse to select the part of your compound that you want to generate new bioisosteres and replace. Down here you'll click next. Once that loads, you'll see it pop up here in the window, and you can go ahead and save this as your name. So for this tutorial, we'll put it as test query.oeb.gz, and we'll go ahead and save that onto the desktop. This will open up the BROOD window again, and from here you can run BROOD. In this box here where it says choose a query, you can open up the file you just made, and you'll see it pop up here on the right. Next you can press setup BROOD, and in the output profile you can just rename that. Again, for here we'll put test BROOD. Then you want to go down here to advanced output. You want to change your maximum size to 200 there, and then you can just run this. So this will typically take a couple of minutes depending on how large your compound is. You'll see here on the bottom right there is a progress bar. So for the sake of time in this video, I'll go ahead and just cut to the end. And as you can see, BROOD is almost done processing for this compound. Once it's done, it'll pop up the analogs in the top right. For this particular compound, there were 7 clusters of them, including the initial query for the lead compound that we uploaded. And in the bottom, there'll be a scroll down where you can see all of the analogs listed here, and you can also scroll to the right for more information, other properties such as seen here, testing for Lipinski's rules. So you're going to want to press open in Vita, which will of course open Vita, and just open this. You can see here that it has all of the clusters shown. Here in the window you can actually click list window, and it'll show you all of your analogs within the clusters, numerically of course. You can also scroll down here and display more structures. 8 typically should be plenty, but you can go up. Not quite sure what the maximum would be. You can also filter it by the heads of the clusters or by showing each analog displayed on the grid windows to the right. So we'll switch back to heads. Here in the list window you can click through, and if you press the green dot there, it'll pop up another one in the window. So you can do that for as many as you wish as well. Once you've looked through them all and chosen your favorites, you can then highlight in the list window, and you can go down here and click add to favorites. You can also click in the right grid as well and add to favorites. So we'll go ahead and just add a couple here. let me see, 4 is good enough. So here we can save, and you're going to want to save it as your name, which again we're naming it test. So we'll save this as test library2.oeb.gz, and this will save to your desktop. Let's go ahead and close these out real quick. A bit hard to see there, but if I drag it over here, you'll see that it's saved on the desktop as your test library2.oeb.gz. Good luck, have fun, and thanks for watching.